listen, Mr. Johnson. I'm not prepared to discuss the matter. I'll have our PR department get back to you as soon as possible. That's right. Goodbye.
Dr. Stein's office?
Yeah, Markowski. Is he there?
One moment, please.
Stein.
We got trouble. I just had a call from an English journalist.
Yes.
He knows about the shutdown. He's asking what progress we're making.
How does he know about it?
His sources are confidential. But I'll look into it. I guess we'll have to brief our PR people. Will you do it, or should I handle it?
Leave it with me. But make sure that no one else speaks directly to any journalist.
I will.
Oh, excuse me. Yeah. Ah, Mary. Allow me to introduce you to Roger Steele, Professor Mary Edwards.
How do you do?
How do you do?
Roger advised us on the choice of materials for the space unit, especially the outer casing.
Oh, so you're an expert on materials?
Oh, expert is a relative term.
How long have you been in Germany?
I came here 10 years ago, part of the brain drain. EAU offered me a job, and I've been here ever since.
Well, we need your advice again, Roger, urgently. Have you seen the log of the breakdown?
Yes. Isn't there any explanation as to why the speed of your peristaltic pump dropped suddenly by half?
No.
Well, it seems to me that only a completely random event can explain it.
Oh?
Look, suppose a solid object, such as a meteorite, penetrated the casing of the unit. If it struck the tachometer or some other vital part of the pump, well, it could have caused a sudden drop in speed.
Well, that's always been a possibility.
Possibility.
We discussed that right at the start of the project. These are all composite bonded structures suitable for use in space. Generally, you have a honeycomb center, like this, with flat boards or skins stuck on either side of it. It's called a sandwich, for obvious reasons.
Not very rigid like this, is it?
Not at all. Nor are the laminated carbon fiber skins. But when you put the core and the skins together, it's a different story.
Mechanically, it makes sense. It's like forming a series of steel girders, each with an eye section.
In proportion to size and weight, that's stronger than steel girders.
What's this one made of?
Now that's formed entirely from man-made aramid fiber, core and skins. It's the lightest material available and also the toughest. It's used to make bulletproof vests. But there is one problem.
It's the most expensive, right? And you don't get many bullets flying around in space.
But you get meteorites. Much the same thing.
True. But that material, that thick, will resist the impact of small meteorites. But you need thicker casing to stop bigger ones. It depends how much you're prepared to spend to protect your unit.
There's always a compromise. What do you recommend?
I would advise the aluminium core with the carbon fiber skins to give you the best protection relatively cheaply.
Well, that's good enough for me. Wilhelm?
Well, you may be right, but forgive me, before I buy anything as important as this, I must be satisfied about many things. The manufacture, the testing, and so on.
There could be difficulties.
Oh, why?
The manufacturers are very secretive for industrial and military reasons.
So are we, but we are a potential customer. I'll see what I can arrange.
Morning, Mr. Seabrook.
Morning.
Have you got your identity card with you, sir? Thank you, sir.
I hope you've got my visitors on your list.
Mr. Schroeder and Mr. Steele.
That's right, from Germany.
Germany, eh?
They work for an American called Markovsky.
No Russians, Mr. Seabrook?
It's all right. They represent a very respectable firm.
I'm glad to hear it.
Just make sure the blinds are pulled down, know what I mean?
I'll see to it.
There's approximately 15 kilometers of acrylic fiber on each of these cheeses, as we call them. Now I'll show you how we convert it into carbon fiber. The first job is to oxidize the acrylic fiber by passing it through a low temperature oven before the high temperature processing. Otherwise, it would simply burn.
It's changing color.
Yes. This is where it goes black. Now the fibers pass through a much hotter oven, up to 1,000 degrees. The fibers are carbonized as they exude about half their weight in the form of gases and tars. In the last oven, the temperature goes up to 3,000 degrees. The last unwanted elements are removed, and we produce a material which is 99% carbon. The atoms are now arranged in a crystalline graphite structure. And here's the finished tow. It contains up to 10,000 separate filaments of carbon fiber, each filament about 1/8,000 of a millimeter in diameter. And that's the basis of resin-bonded carbon fiber materials. If you'd like to come this way. Of course, we can produce different qualities of carbon fiber with different properties by changing the conditions in the manufacture. The line is computer controlled, and every aspect of the production is continuously displayed. You'll forgive us if we don't show you the actual figures.
Yes, they're very cautious. They didn't want to reveal too much information.
Herr Schröder,
Yeah?
rufen Sie bitte Herrn Dagen an. Er hat gerade angerufen.
Ah, danke.
Oh, Wilhelm, can I see you for a moment?
Yeah, sure. Excuse me, I'll be back in a moment.
Wilhelm,
Yeah?
you haven't been speaking to any journalists, have you?
What about the shutdown? No, of course not.
Someone has. Just had a call from an English journalist. He knows we got problems.
An English journalist?
Someone just doesn't know the meaning of the word security.
The question of security came up again that evening. Wilhelm and I had been to see how the carbon fiber tow was processed. It goes through various processes and becomes what is called pre-preg tape. For aerospace purposes, the tape has a standard width of 300 millimeters.
Seems very thin.
Several sheets are laminated to form a skin. Look. If you lay the sheets with the grain going the same way, you get maximum strength in that direction. If you lay the grain at right angles, you get strength in both directions.
And what do we need for our casing?
At least 4 sheets laid at 45 degrees to each other to take stress in all directions equally.
Let's see the middle part of the sandwich.
The aluminium core, that's in the other workshop. They print epoxy adhesive on aluminium sheets in a striped pattern and bind the sheets together with heat and pressure. They cut slices from the Q block, as they call it. The bonded sheets are expanded, forming the honeycomb shape. Then they stack the cores in a stabilization oven for a couple of hours to relieve stresses. After that, it's a question of quality control and testing. Finally, the sandwich is assembled. So, we agreed on an aluminium core with carbon fiber skins.
That's right. From the test results, it looks as if a 10mm core will be adequate.
We want a curved shape for the casing, so it'll have to be formed in an autoclave.
Oh, we'll subcontract that job to the aerospace people.
Good. Now, what about attaching components to the casing?
Well, you know my feelings on that. I'm used to nuts and bolts.
That would mean modifying the structure to take the bolts. And that means weakening it. Everyone agrees adhesive is all you need.
Well, I suppose I'll have to get used to the idea of sticking factories together with glue.
Good evening, sir. Mr. Schroeder, Mr. Steele.
I'm Steele. This is Mr. Schroeder.
Mr. Seabrook asked me to call. I'm a security officer from his company.
Security?
You were visiting the premises today, sir.
That's right. We were interested in your firm's products.
Only to buy them, of course.
I'm very glad to hear it, sir. The reason I came is, I think one of you left this behind.
My file.
I was asked to deliver it in person, sir, just in case it contained anything confidential.
Thank you very much. That was most kind of you.
Not at all, sir. Good night.
Good night. For a moment, I thought we were going to be arrested. Ah.
Right. Oh, Mary, Stan would like a word with you.
Yes, of course.
Sorry I took so long. Now, here is a copy of your original report.
Oh, hi, Mary. Come on in.
Dan?
Sit down. This investigation, you do know it's confidential, don't you?
Why do you ask?
I just had a call from an English journalist named Johnson.
Edward Johnson.
You know him?
Yes, I know him quite well.
Well, he seems to know all about our shutdown.
I see. And you think I must have told him? Stan, how is it that a highly qualified space engineer can put 2 and 2 together and make 5?
Well, how else could he have known?
Edward Johnson's a good journalist. He did a big write-up on the Carsat launch and he's familiar with all the payloads. It probably occurred to him to make a routine check.
Even so, how could he have known about the shutdown?
A lot of people must know about it by now. Supplies of components, the people at ESOC.
It's unlikely they'd say anything.
But it's not unlikely I'd be stupid enough to talk to a journalist. Somebody may have told him that I had to leave for Frankfurt urgently. He's quite capable of putting 2 and 2 together and coming up with the right answer.
All right. I'm sorry. Really. I'm a bit uptight. Maybe I did jump to conclusions.
Maybe.
Listen, we all need to relax. Come to dinner tonight. My place. Wilhelm, too.
All right. Thanks.
Yes, I see.
Hello, Roger. Sorry to keep you.
Not at all.
What do you think? Has a meteorite caused our problem?
No. No, I don't think so. A solid object would have left a gap in the casing. Now, if that had happened, your temperature sensors would indicate a drop due to loss of insulation. They don't.
Right.
That's true, and it confirms our own thinking.
Right. Well, anyway, thank you for coming.
Not at all. Sorry, I can't help more.
Take care.
See you, Wilhelm.
Bye, Roger.
Well, that's another dead end. Cross it off the list, Wilhelm. Oh, and come to dinner tonight, will you?
Yes.
Good.
I'm coming too.
Huh?